The Rock Whisperer. Do you hear the earth talking to you?
Rocks and Minerals, Metamorphic Rocks, Unit 3-5. So we've talked about the three different rock classes. You've done the notes on igneous. We're moving on to the next type of rocks, which we're going to talk about are metamorphic rocks. So as we've already said, metamorphic rocks form under great heat and pressure. So we're changing rocks. But metamorphic rocks can form from any type of rock. You can take a sedimentary rock, add heat and pressure, we get a metamorphic rock. We can have an igneous rock, heat and pressure, metamorphic rock. You can actually take some metamorphic rocks and add heat and pressure, and you'll get a different metamorphic rock. And we just need to remember that that's going to occur because of the tremendous amount of heat and pressure that is going to be applied to those rocks that are changing it. With that being said, there are two types of metamorphism that occur. So the first one that we're going to talk about is going to be regional. It means it's over a region, right in the word. So that means there's a large area that's undergoing heat and pressure. So in this diagram that you see here, it shows you right here that you have granitic magma, or magma that is making up granite. And down here we have andesite magma. And it shows you the low temperature and pressure. That's just the magma in the earth. And then we have a high temperature and pressure. And right here, because of the high temperature and pressure, is where you're going to have metamorphism occurring. Over here we have lower temperatures, but relatively high pressure. So over in this area also, you'll have some metamorphism occurring. And notice that those are usually occurring within the lithosphere, not so much in the crust, where you might still have magma. The other type of metamorphism is called contact metamorphism. And that is when magma or lava comes into contact with another type of rock. And that is going to be what causes the change. So if we look at this diagram here, we can see that we have layers of rocks: shale, slate, shale, some limestone, quartz, sandstone, and some more shale. When the magma pushes up through the rock layers, when the magma comes in contact with the limestone, we wind up with marble. When the magma touches the sandstone, we have quartzite. And when the magma hits the shale, we can wind up with hornsfeld, or depending on the amount of heat and pressure, you may actually wind up with slate. But you can tell that the only metamorphism is right along the edge of the magma, where it came in contact with the other rocks. We talked before in the first one of the earlier videos about different textures, and we said that textures are not whether rocks are rough or smooth, but what the minerals and the crystals are doing and the size of those. Well, for metamorphic rocks, we're talking about two different characteristics. We're talking about whether they're foliated or whether they're non-foliated. And what foliation means is, does it have layers and banding, or are there no layers and banding? And in these diagrams, and hopefully you can see it better on the video, this one is really obvious to see. You can see the layers or the bands that are occurring in this particular one. In the slate that we have here, you can kind of see some of it along the edge right here, that you would be seeing some of those. I know many people have talked about seeing shale, and you can see the layers in that easily. And I know it's hard to see in this particular diagram here, but in this one the minerals are lining up. So all the platy mica, and you can kind of see it, one crystal right there, but all the mica that would be in this are all going in approximately the same direction. These rocks down here do not have any of those layers or alignment in them, so they're non-foliated. So I'm going to go through a series of examples, because we talk about metamorphic rock. It's a rock changing from one type to become another type of rock, and that's going through the metamorphism process, which is adding heat and pressure to those. So in this particular case, we have sandstone, and sandstone changes to quartzite. And if you were looking at this under a hand lens, what it looks like is these individual sand grains are kind of somewhat fused together and have become one kind of solid block. In this particular example, we have limestone, and limestone turns into marble. The color has changed, and that does happen sometimes with metamorphic rocks. And the last couple that we have here, when we look, we have in this one, and there we go. So we have two different types of granite, and this might be more of a diorite here, turns into a gneiss. And we can see that we have this similar composition here. Then we have the second one, which is granite down here, and this pink in here is the potassium feldspar that you saw in the mineral identification lab. And that turns into this type of gneiss, and I found a picture that actually shows some really good distortion in the banding and foliation that you see in some of the rocks. They're not always that distinct. Sometimes they're more straight line like this one up here, but we can see that this has the same color composition, just slightly different. I know these look almost identical, but we have shale right here, and that shale will turn into slate. I know in one of the previous slides we talked about that shale can turn into hornsfeld, and depending on the degree of metamorphism, it can turn into slate. In this particular case, we have a conglomerate, which is a sedimentary rock, which we'll talk about in the last video. And we can see there's a variety of sizes of different pebbles, sand, and sometimes we can get into cobble-sized things. And then when we look at this one, we can see they're relatively rounded with the conglomerate. But when we get over here into the metaconglomerate, you can see what's happened. These now seem to be more elongated and kind of oval shape in this particular diagram. Why? Because we had heat and pressure, and that pressure squished things and kind of made those particular pebbles within here become elongated. And the last one that we have, again, if you have slate, which is already a metamorphic rock, we talked about that slate can become a rock called schist. And that slate then can come in and have mica crystals in this. And you'll see this a lot better when you actually have a sample in class that you can view.
Don't forget to listen to the earth. You just may hear it speak.